Okay, so before we get started today, we have a couple important announcements. First of all, I will not be here next week, so no class next week. However, that does not both. No class next week, both days. Okay, so however, okay, you are responsible for the lectures. So I have lectures posted for both days. So I have lectures posted for both days. And okay, watch them. You are responsible for them. Okay, they will be on the exam. So these are lectures that I have recorded in past years. So they are exactly like a normal lecture, other than the fact you cannot ask me questions. And if you have questions, I'll be available via Piazza, not at that time, but you can send questions via Piazza and I'll be happy to answer them. So you are responsible for the lectures, and there are labs next week. Okay? Lab is held as regularly scheduled. Hey there. Give me 1 second, okay? Okay, so if you are, just 1 second, okay? So if you're wondering where are the lectures located, if you go to lecture notes, you'll see online lectures. And if you just click through, for example, I will have this updated. This is not the February, well, it is the February 6th lecture, actually.
So let's get started.
Okay, just like I normally start.
Finishing up with classes and...
Okay, so you will be expected to watch both of those. Why I get encounters with elephants when the elephant whisperer with constructor separate compilation, I do not know. So shows you artificial intelligence not always the best at working. Okay, so that's where the you can find the lectures. Yes.
I noticed for some of the past video lectures that there was a disconnect between visual and audio. Like the visual was way behind and the audio was way ahead.
Really? Is that just happening? Wait, is that? So the lectures I'm posting are actually, for the most part, for this semester. So is it actually?
Yeah, it was like for lecture 1.
That it was. Okay, thank you. Let me have a look at that, because I don't think that's past lectures. I think that's this semester's lectures that are having that issue. Okay? So let me look into that. Thank you for telling me, because I didn't realize that was an issue. I guess other people are having that issue as well, if you're watching the video lectures? Pardon?
I have not had that issue, but I've not watched
every. Okay. Was it just lecture 1, or have there been multiple ones?
It's only one I watched, honestly.
Okay. So I will check it out. Okay, so going to pause here because our folks from International Paper are here. So, second. So since I won't be here next week, the other important thing is that the week after that, on Thursday, September 27th, so 2 weeks from today, we have a midterm in here. And the day before that in labs, so 2 weeks from yesterday, we have the coding portion of the midterm. And the way the midterm works is that typically there's 2 coding questions, and I give that in the lab on the Wednesday the day before. You have an hour to work on those coding questions, and you'll work on it using a website called Code Assessor. So some of you may be familiar with it from 102. You don't have to use it. I mean, you can simply use it as a text editor if you want. Okay? What I don't expect necessarily in an hour for you to get your program to work. What I want is to give you the ability to write it out in something that I can more easily interpret, because your longhand is often horrible. Sorry, but it is. Also, if I have you do it longhand, what I often get are things that look like this. D, 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 D. Whoops. Okay, and it's really confusing. It's really hard for me to interpret what you're doing. Okay, so by having you type it out, it's a lot easier for me to read your code, plus it's a lot easier for you to delete stuff, add stuff, etc. Like I said, you don't have to use the compilation feature of Code Assessor. You don't have to use any of the other stuff. You could just use it as a text editor and save it, okay? The compilation features, the testing features are there to help you, because sometimes you make silly mistakes and the compiler can help you with that. But as I say, in an hour, not all of you will be able to actually get it to compile and work. That's not what I care about. What I care about is also, if I gave you these coding questions in class, you wouldn't have as much time to work on them. By doing it in lab, you have a full hour, you have half an hour to work on each of them, as opposed to probably just 15 to 20 minutes scribbling by longhand. Okay? So I think there's advantages to doing it in the lab. And you'll get a one-page cheat sheet front and back, so you should take advantage of that. I generally recommend you put code fragments on it. Just putting code definitions on it won't help you. You're writing a program. So what you need is program fragments that show you how to do things, that you can use as templates, modify those templates to fit the problems. Okay, because you can be pretty sure that the problems you get on the midterm are going to roughly parallel what we either have presented in class or the labs. Now, the paper version on Thursday is more just working things out. Like, we're getting into hash tables next week, so there's always a problem on hash tables where you have to put things in the right place in the hash table. Or generally there's a question on how you compile stuff. So I give you some files, I ask you to show me how to compile them, okay, using the command line tools. And I haven't done it yet, but by this weekend I will have it up. So I don't want Firefox, I want Chrome. Okay, so by this weekend, this exam link will lead to actually sample previous exams. And it's not actually available yet, but it will be by this weekend. And I will also be putting up on CS102 dev, so not cs102.eecs, that's the site you used in CS102. We have a separate site, CS102 dev, that we use in CS140 for Code Assessor problems. So I will also be making the past midterm coding problems available on Code Assessor so that you have an opportunity to work with Code Assessor if you've never done so in the past. I think it's pretty straightforward using Code Assessor. If you haven't, you can always ask the TAs if you have any issues with how to use it. It was meant to be usable basically with less than 10 minutes of instruction. Basically, you just have, I'll show you in case you haven't seen it. And we do have some students from Palisippi, I know, this semester who have not. So basically, when you go to the website, you enter your net ID and you enter your net ID password. Okay, so it comes up to the screen. You select problem selection, and you will go to CS140, and you will see a variety of potential problems. You'll select one of them, and it will come up with boxes where you enter your code. There's instructions at the beginning of each box, And also you have a worksheet that describes the problem in more detail. You have a button for compiling the code, a button for testing the code, and a button for saving your work. But every time you compile your code or test your code, it automatically saves your work for you. And then hitting grade this part runs it against our set of test cases to see if it works or not. Again, we don't expect your code to necessarily work. You can get a lot of credit just for having the logic primarily right. And under test your code, it always comes up with some sample input that you can use, and you're free to modify that input as you see fit. So it says test with this input, and it's if you also just want to see what the output should look like, you can say show instructor output, and that will just run our executable so you can see what your output would look like if you're not sure what it should look like. So that's pretty much it with Code Assessor, and sometimes we have you write multiple fragments within the program. We often give you some scaffolding, so here you can see that we already have a bunch of the program written out, so you're only writing part of the program. So questions about that? Strongly encourage you to do the test problems before the exam just so you're a bit familiar with them. Okay? So again, that's in 2 weeks, but since I won't be here next week, wanted to go over it today. Now that said, I believe the video lectures will also go over it. So ignore in the video lecture when it says like February 6th is the midterm, because obviously that lecture was from last semester, but everything I say in there otherwise is also true about the midterm and the lab part of it this semester as well. Okay, so today we're going to go through a number of things. So first of all today, I want to go through some Lab 3 hints. The TAs probably went through it a bit yesterday. I want to go through some more hints today. Then I want to go through a little bit of the string find and substring thing from the procedures lecture last time, and finally we're going to get into classes today and continue with classes on Tuesday, which of course will be part of the video lecture on Tuesday. So just a couple things on Lab 2 and 3 because they both deal with PGM files. So important thing to remember, because we've seen this multiple times now, it's columns then rows in the PGM files. A number of times we've seen students posting to Piazza saying, I can't figure out what's wrong, and it turns out they're doing a CN first into rows and then into columns. Okay, easy mistake to make. You CN into columns first, rows second. Second thing we're seeing is the reason students don't often catch this error is that they're using n by n matrices, like 3 by 3 test files. You'll never discover the error because the rows and the columns are the same. So it's important when you're doing testing to not use square PGM files because your code may well work on a square file, but it won't work on a rectangular one. So, you know, use a 4 by 3 or use a 3 by 4. Just try not to use square PGMs because that's not going to reveal a bunch of these problems. Questions about that? Okay, so on Lab 3, there's a couple programs that you are being asked to write and can be a little difficult to wrap your head around how to do them. And again, I understand the TAs may have gone over this in lab, in which case repetition is the key to learning. And why is that? Because repetition is the key to learning. Okay, so that's a saying that I learned from a professor when I first came here. So one of the programs is PGM Pad, where you're putting a border around your PGM file. And let's see if he has an actual example of that. There it is. So here he's padding Rodney's PGM file. He's putting a black 30 pixel border around it. And we tell you you're only allowed to use a single 2D vector for this problem. So a second thing for lab 3 I wanted to emphasize is make sure that you are paying attention to the lab constraints, that you don't ignore the lab constraints. So they will tell you, if you have to read through it, but somewhere, there it is. So when it says you may not declare another 2D vector to hold the padded PGM file, and you can accomplish this padding using only the original PGM vector, we mean it. You're only allowed to use one 2D vector, which is the original PGM file. So make sure that you adhere to the problem specifications. Now, that can create some issues for you because while PGM Pad may be very easy if you could simply have a original, so you saw the padding, it might be very easy if you could say, okay, here's my original one. Now I'm just going to create a slightly bigger one, and I'm going to copy this one here over to here. That's kind of makes it easier. It's not so easy when we say, okay, you have to actually modify this thing right here. Now you have to figure out how to essentially transform this one into this one over there. And you're going to have to be careful in how you do it. Okay? So let's just take a very small example. Let's say that you had a, let's see, 255, 40, 30. I'm going to give you a 2 by 3. Okay, so this is your original one. Okay, and let's say we tell you to pad it by 1 pixel. Okay, so if we tell you to pad it by 1 pixel, that means that the first row is going to be the padding and the first column is going to be padding. So it should be pretty clear that pixel 1 is going to go at location 1, 1. Okay? So there is a right way to do your padding and the wrong way. So basically what you're going to have to do is you're going to first, or second, but we'll just say first, you're going to have to copy your pixels to the right place. So 255 is going to have to be copied from location 0, 0 to location 1, 1 in this case. Pixel 0, 1 is going to have to be copied to location 1, 2, and so on. So let's say you do this in the obvious way. You start it and your matrix, let's actually do the matrix. Okay, so draw out the things here. So originally, it looks like this. I'm just going to put a 2 in here because I don't have enough space. And here it's 1, 2, 3. So I just didn't have enough space. So 0, 1, 2, 3, 4. 0, 1, 2, 3. And Yep. So you're going to have to, first of all, the padding is 1 pixel on each side. So actually you're going to need 1 pixel on the left and 1 pixel on the right, 1 pixel on the top, 1 pixel on the bottom. So your first thing you have to do is resize the PGM vector. Okay, so the first thing you'll need to do is resize the PGM vector. Okay, then you need to, at some point, move your pixels. So let's say we start at the upper left-hand corner here, and we move the first pixel, which is 255, to its proper location, which is, as you can see here, 1, 1. Okay, so we move 255 here, and we end up, okay, with 255. And then I move 40, this one, to its new location. Here's 4. I'm going to move it to its new location here. Does anyone see something that's going wrong? You're overriding. Right, so the problem is you are overriding pixels that you'll need later. So starting at the upper left-hand corner and trying to move the pixels over is going to result in your clobbering later pixels in your picture, and you're not going to get the right result. So the solution is not to start at the upper left-hand corner. The solution is to start at the lower right-hand corner. So the solution is start at the lower right corner. And that will work. Okay? And I suggest you then move the bottom row first, then the next to bottom row. So you basically work right to left, top to bottom. So normally you'd think of going left to right, top to bottom, right? So what I'm saying is what you really need to do is go, instead, what you need to go is right to left, bottom to top. So starting with the bottom right-hand pixel, and that way when you move it, you're moving it down, right? So you're moving, if you start from the bottom right, so I'm going to go back, this is 40, this again is really 2. Okay, so now when you move 30, you're moving it in this pixel right here, you're moving it into virgin territory, so there's no trouble. Okay, next, because you're moving right to left, you move this one, you move it over here again, you're moving it into virgin territory. Here, you're moving it again. So now once you've done that, this row right here, you can now overwrite it because you've saved it. Okay, you've moved it into its proper location. So with the padding problem, you want to start at the lower right corner and move the pixels from there. Okay? Any questions about that? Okay. Now, there is a second problem, which is kind of the opposite of PGM pad. It's called PGM crop. Okay, in PGM crop, you're taking part of a picture. So in this case, part of red. So here's part of red. This is from the 70s show that Dr. Planck liked. How many have seen the 70s show? Okay, fair number of you. So he always liked red. So here you see it going, and he's getting cropped. What that means is that a part of red you're taking, say, this part of red, and you're moving it to there. And then you're resizing it after that. So this is kind of the opposite of pad. Now you're moving something from the middle of the vector to the upper left. Now it is right to start from the, now you really do for crop, okay, so for crop, you do want to start, okay, go left to right, top to bottom. So it's the opposite. I'm sorry, yeah, top to bottom. Okay, starting at the upper left corner. And when are you going to do the resize, at the beginning or the end? The end. What's going to happen if you do it at the beginning? You're cutting off all the important information. If you do the resize right away, you will immediately cut your PGM file down so that you have red's forehead. And it will throw out the rest of the PGM file. So it's the opposite from pad. I have no idea, even though my machine is muted, why it is coming in with these things. And my mail is off. So actually, let's try also killing off Outlook. But it's muted. It shouldn't be making these noises. Okay. So crop, you move the upper left first. Pad, you move the lower right first. Okay? So that's important because you're only allowed to use one 2D vector. Okay? Then the final thing I want to point out is with the paneling. Okay? There are multiple ways to do the paneling. So I'm only going to tell you one way that you could do it, which is probably not the way you would think of, and that's okay. Not asking you to do it this way, but there is tricks using mod that you should be aware of. So most of you are probably more likely to do this paneling. So with paneling, you're taking an image, and it's a little bit like the checkerboard from Lab 1. You're having to create multiple instances of the panel. Okay? Except now you have a 2D vector available, so you don't have to be quite as careful with your way you set things up. I will tell you the way you did it line by line in Lab 1 would work just as well here. So one thing you really could do is basically if you have rows by columns, okay, and you're asked to do, let's see, a 2x4 panel. So you're asked for a 2x4 panel. Whoops. What that means is that when you're done, you're going to have 2 rows and 4 columns of these things, which means your final thing is going to have 2 times that many rows. And how many final columns will you have? If originally you have this many columns and you're creating a 2x4 panel, 4 times columns is going to be your number of final columns. So you really can write just a loop that looks like for essentially r equals 0. In this case, r less than final rows, which I'm abbreviating. Well, I'll just write out final rows, r plus plus. And you can do the same thing for the columns for c equals 0, c less than final columns, c plus plus. Okay, I'm going to put my brackets here. Now you have to assign a value to effectively PGM RC. And the way you can do that is with the mod operator. Okay? So if you are, let's just think about this for a moment. Let's give this some actual texture. So let's say the number of rows originally was 3, the number of columns was 4, and we're producing a 2 by 4 panel. Okay? So originally, it should be pretty clear that in the new PGM that you're creating, the first 4 columns and the first 3 rows are exactly the original one. So what happens when we're out, say, here? Let's say that we were at column 4, or row 4, and column 5. The question is, which pixel should we be using from the original PGM? Okay, so it's one of the original ones. Well, this one started at row 3, so it's going to be 3, 4, and 5. And this one started at column 5, so 5, 6, 7, 8. So if you're working through it by hand, what is 4 going to translate to in the original? Which row does 4 match in the original one? 1. Okay, so 4 matches 1. Okay, 3 matches 0. 4 matches 1. 5 matches 2. Over here, what column does 5 match? 0. 6 matches 1. 7 matches 2. 8 matches 3. Well, there's a trick that you can use, and that trick is using the mod operator. It turns out that if you mod R with your original number of rows, and if you mod C with the original number of columns, you will get the appropriate row and column from the original PGM file. So for example here, working through it, our row is 4. We mod that with the number of rows 3, and lo and behold, we get a remainder of 1. We do that with, let's see. I was wrong here. 5 is not 0, sorry. This was starting at down here. This was not starting at 5, 6, 7, and 8. Okay, it goes from 0 to 3. This is 4, 5, 6, and 7. Okay, actually 5 maps to column 1. And again, if we do 5 mod 4, we get 1, the remainder. So mod is really helpful in picking out the original row and original column that we need to use. Okay, in effect, what you would be doing, what you were probably doing here, was in your mind you're saying, okay, we're starting at 3 for the row, and I'm subtracting 3 from 4. Well, the mod operator effectively is doing that subtraction for you. Let's say now we were at row 7. 7 mod 3 is 1. Okay, again, the mod operator is effectively subtracting 6 from 7. It takes the integer quotient and effectively subtracts out that, just leaving the remainder. So mod is doing exactly what you would probably be doing in your head, which is figuring out how many rows you are from the start of this current panel, and then you would take that corresponding row from the original PGM file. So this is a cute application of mod. So I'm just going to leave it here and let you fill in the blanks. But the mod operation is probably the easiest way to write the panel program. Some of you will use 4 nested loops, and that's fine. But you can get away with just writing 2 nested loops if you use this little idiom that I just showed you with the mod operator. So questions about that? Yes?
So are you allowed to use an empty vector for this one, or do you have to use the original?
You have to use the original vector. That's the point. You have to use the original vector. You'll have to resize it first. Okay? Just a sec. Send back first.
Can you go back to the last slide real quick?
Yes. You just copying it down? Okay. Thomas.
Just to be totally clear, the top left matrix is your original.
That's right. The top left is your original, and then you're creating, in this case, it's a 2x4, so you're creating 7 copies of it. So in fact, you really don't have to, the first panel is already there, and now you're resizing the PGM file to be enough to accommodate the additional 7 panels. But I'm fine with you starting at R equals 0 and C equals 0, so in effect, the first panel, you're just laying down on top of itself. That's fine. I have no issues with that. That's what this code is doing. The first one is, what you're doing is going to be setting PGM RC equal to exactly itself for the first panel. I have no problems with you doing that. Okay. Other questions? Okay. So, moving on. Dr. Planck, in his lecture notes, I'm going to let you figure out how he wrote the procedures, but what I care about in his lecture notes is what he was doing for the procedures. He had his playlist. Dr. Planck likes music a lot. So he has this playlist of songs and the length of the time. And what he wants to do is cut CDs. I know that's old, but he's cutting CDs that are 80 minutes long. And so what he needs to do is take this playlist and copy songs onto the first CD until he gets to a song that would take him over 80 minutes. And at that point, he's going to start with a second CD. And he'll start again putting tracks on that second CD until again the next track he would put on it would cause it to be over 80 minutes. Okay? I think figuring out adding up numbers to get to 80 is not difficult. Although in this case they're in minutes and seconds, so he's going to convert the minutes and seconds to just seconds. So in fact, rather than saying it's 80 minutes, he's going to say it's 80 times 60 or 4,800 seconds. But I don't think it's particularly hard to convert these things to seconds. You should be able to pretty easily, if you know the number of minutes and the number of seconds, to convert that to seconds. Okay, and then it's pretty easy to add them up. And if you're going to be greater than 4,800, realize you need to cut to another CD. What's not so easy is you're reading these things on separate lines. So on the input, each line consists of a track and a time, but there's an arbitrary amount of space between the track and the time. Plus, you can see that there are spaces between the words and the tracks. So basically, you somehow want the end of the track, you somehow want to get all of the track name into one variable, and then the second field, which is the time, into a time variable. But the problem is you can't just start CNing because there's a variable number of words in each track. So somehow you have to figure out where the track ends and the time begins. And what you are guaranteed is that there are at least 2 spaces between the end of the track and the beginning of the time. So that is a guarantee. There will be at least 2 spaces between the end of a track and the beginning of the time. And that's what you can use to separate the track from the time using find and substring, okay, which is what we talked about find and substring a few classes ago. So he uses getLine to read in a line, and then he uses the find command to find the first place in the line where there are 2 spaces. So we're guaranteed that if there is a break between words, it's only 1 space. So he's using the find command to find the first place where there are 2 spaces. Remember, if there is no such location, then find returns this constant called string : NPOS for no position. That would be an error because there has to be a place in the input where there are 2 spaces. So once he has that, he uses substring to extract the title. That is starting at location 0, and it has length I. Remember, I is the length of the substring. So that gives him the title of the song, which he puts into a vector called songs. Now he needs to find out where, once he has found out where the end of the, so he has found out that the end of the track or title is right there. Now he has to figure out where is the beginning of the number. And unfortunately, that could be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So one thing he could do is he could say, keep searching until I find a character that is a 0 or a 1 or a 2 or a 3 or a 4 or a 5, blah, blah, blah. That's kind of time consuming. So instead, he is going to continue until he finds his first non-blank. So he says, while I am looking at a blank character, I will increment I, which is my index into the string. And when he gets to his first non-blank, that must be the index location of the time. So at that point, he does a pushback again. And notice now with the substring, he only is giving the starting location, because when he only gives the starting location, what is the default length? The rest of the string. So, in fact, that's what he wants because the time is guaranteed to be the rest of the string. So he doesn't care whether the time has 4 characters like here or 5 like it has here, or even, I don't know if any of his, nope, none of his are less than. One of them is 0.42, so this might, he's guaranteeing that his minutes will be a number. Okay, so he's guaranteeing, just like Thomas, he's guaranteeing his times have a number in the minute position, which in this case is a 0. But these 2 lines here allow him to extract the time. Okay, so this is a use of the find and the substring commands to break apart a string when we can't do it with the normal string stream operations, because in this case we don't know how many words are going to be in the title, and while he didn't have any numbers in the title. Oh, he did. See, you can't even check to see whether it is a number because there can be a number in the title. So you really do have to wait until you find 2 blank spaces. Yes, Thomas?
Is there a guarantee that there's no colons in the song title?
Nope, there's no guarantee. There could be. Okay? It doesn't matter because he's looking for 2 spaces. So even if there's colons in the song title, it doesn't matter. He's looking for 2 spaces.
Well, if there was, I would just search for colon and know what you got.
That's true, but there's no guarantee. Just like there's no guarantee that there's not a 3. Okay, so there was a tails 3. What if instead of this being a comma, this were a colon? Okay, there's no guarantees. But you're right. If you could have no colons, then you could do that kind of thing. Okay, so that's the first clever thing he did. The second clever thing is how he went about converting his time to minutes and seconds, because there's a colon in there. And it's important that he break that into minutes and seconds. Now, it'd be very helpful if you could stuff something into a string stream and say that the separator is a colon rather than white space. But you can't. Okay? String streams assume that the delimiter is always white space. So scratch that. Scripting languages do let you break on arbitrary characters like colons, but not C++. So he does something else to break his times into minutes and seconds, and it's right there. So he has his timings in this vector timing. So for each timing, he finds the location of the colon using the find command. Now he does something different. He has the location, the index location of the colon, and he's going to assign a blank space to that location. That is going to give him something that looks like, instead of it being, say, 5:30, he now has 5 space 30 when he pulls this trick. Now he can stuff that thing into a string stream because the string stream does recognize a space. So having made the modification, he now, how do I get, Okay, having made that modification, he stuffs the string into a string stream, and he reads the minutes and seconds from the substring. He does the obvious calculation for seconds, and then at the end, he puts the colon back in the right place. So he restores the string to its original form. So that's the second thing I wanted to show you with find and substring. Actually, he's not using substring here. He's just using the find command to find the location of the colon. Then he's replacing the colon with a space. Then he uses the string stream to extract the minutes and seconds. And then at the end, he puts the colon back in. Yes, Thomas?
Would you say that it'd be roughly the same time if you used scanf? Because scanf will allow you to put the form of the string that you want, even for precision.
Yeah, but we're not using scanf. So the answer is you could probably do it with scanf. But I know you saw it in 130, but in this course, we're actually preferring that you use CN and string streams so that you get used to them. The answer is yes, technically there's a way to do it with scanf.
I was just curious if it was faster.
Probably faster with scanf. Because scanf, yeah, probably faster, but don't worry about it. It's a good question. Other questions? Yes. Okay, right here. Mm-hmm. Okay, so the timings is a string, right? It's a vector. So timings, actually, I should go back. So timings is a vector. It's declared as a vector of string. Okay, so the way timings looks, okay, each entry is a string. Okay, but remember, a string can be treated like a vector. So you're allowed to index into a string. Okay, so this first one, timings I, gives us the string, say 530. The second index, the colon now, this one right here, gives us an index into the string. So that's what's going on. Yeah, it helps to, I'm very visual. Believe me, when I used to go through this as a student, I used to have to draw stuff out like this because it just looking at the code didn't make sense. I had to draw pictures just like this. Yes.
Actually, now that you brought that, why is colon spelled out instead of just like?
Because that's not, colon is the index location. It's about, in this case, it is the number 1. It's not a colon. Don't worry, but that's, again, names can start to confuse you, right? Maybe colon location would have been a better, or index would have been a better name for the variable, because then it wouldn't be quite so confusing. So colon index might be a more descriptive variable name. Okay. So I just wanted to show you those two examples of using a substring and a find, because Dr. Planck sometimes does that. Okay, and again, the reason we did it was we had to use them to break up these strings into two fields where we couldn't any longer use a single space to break it up. We had to use a different technique. Okay. So the last thing today, we have 2 lectures to go over it, is classes. And let's see here. I'm actually going to go to the book quickly. Actually, no. I'm going to go to Dr. Planck's notes. Okay, so he goes through this big roster example in his notes, where what he wants to do is create an HTML table of photos and optionally names under the photos so that he can memorize the names of students. Okay, some unusual students, but there you go. This is Dr. Planck's beloved basset hound, Harvey, not Henry. But at any rate, so he wants to create this HTML table, and he's going to use this example to motivate why we use classes. And he creates this class roster, and you'll see that he has some methods for adding a name to his roster and for printing the roster. And he has a vector for holding his names. And you'll see that there are the access protections public and protected. Just a second. Okay. So public means that this is visible throughout the program. So any function in the program is able to access public members of a class. Protected means that only members of the class can access that variable. So in this case, only the methods add name and print are allowed to access names. And we, in general, make public our methods that will be used by the program, and we make protected all of our data. So usually, we make the data Okay, so we make the data protected. Okay, and usually our methods we make public. And the public methods, you will often hear them referred to as the API, which stands for Application Programmer Interface. So you'll often hear the term API thrown around, and that's what it stands for, Application Programmer Interface. It's the interface the programmer has with the class. It's allowed, the program is allowed, or application programmer is allowed to use those methods in the class in order to manipulate the data in the class. But the application programmer cannot get directly at the data because it is protected. So as a general rule, we protect our data and make our methods public. Yes. Okay. Now, question is, why do we do it this way? And the answer is the data is essentially where we have our implementation. And we want the flexibility to change our implementation without breaking the rest of the program. For example, in Labs 2 and Lab 3, we make you, well, especially in Lab 3, we make you implement a PGM picture with a 2D vector. What happens if we later want to change the representation from a 2D vector to either a 1D vector, which is possible, or to a 2D array? If the data was public and the application program was able to directly reference the data, the program would break, especially if we converted the 2D vector to a 1D vector. It would break the application program. But if by making it protected and making the application program go through these methods, the application program doesn't break because the method names stay the same. And we change how the methods are implemented so they can work with either a 1D vector or a 2D array. And we recompile that one file. But the rest of the program is untouched. So that is the reason we make our data protected, because we want to, in effect, protect the application programmer from changes to our implementation. We don't want changes to our implementation to break the program. And remember, in many cases, these APIs are exported to millions of programmers. Google does it with its interface. There are ways that you can hook into Google through the Google API. Well, if Google went changing its, if it made its data public and allowed the application programmer to get at those variables, and then it changed its representation from a 2D vector to a 1D vector, it would break thousands of programs. Okay, so we make it protected. Yes? Okay, good question. The question is, what's the difference between protected and private? And the answer has to do with something called inheritance, which you won't be exposed to until either 302 or 365. But you're allowed to do something called making a subclass. And if you make a subclass of roster, let's say we made a subclass called student roster, then protected would mean that the subclass could inherit and look at these members, and private would say they can't. So it's private says everything is really restricted to just members of this class. Protected says it's restricted to members of this class or any subclass. So subtle. Okay, we prefer you use protected because most of the time when you subclass, you want the subclasses to also be able to see it. Okay, so private, you see in some textbooks, it's now considered very bad to use private. Protected is what you're supposed to use because it increases the flexibility of your implementation. So we don't show you private. We want you to use protected. Okay? For this class, were you to use private, your programs would run fine, but in a future class, it would break. Okay, so please use protected. Other questions? Okay. Now, the second thing is that we are putting this class declaration into a separate file called a .h file. So we're putting it into a file called roster.h. And we're going to put the function definitions into a file called roster.cpp. Okay, so the class, specifically the class function definitions. So this is the first time, perhaps, that you're seeing us put the class declaration in a separate file from the class definitions. And the reason we're going to do that is that in very large programs, such as the type that Google writes or Amazon writes, there may be tens to hundreds of files. And every single one of those files is going to need to use the same class declaration. So if you can do one of two things. You can copy that class declaration into every one of the 200 files. How are you going to feel about that when your boss tells you that we're changing from names being vector to names being an array? You feeling good about modifying 200 files? Probably not. So .h files give us the way to extract this common code and put it in a file which we can then include using the #include statement. Okay? So we are going to put the class declaration into a .h file along with any include statements that are required, such as we need the string in order to recognize string. We need vector for the vector. Quite frankly, IOStream and CStandardLib are not necessary here because they're not using any of the functions from that library. I'll tell you why later why he's doing that. Okay, now when we write the roster.cpp, which contains all of the function definitions, we first include the .h file. And here he's saying roster 01, roster 02 because he's doing incremental development. And he had to, as he added more and more things to his files, he had to give them different names because he wants you to be able to look at each one of them. But in general, this would have simply been named roster.h. Usually, this would just be include roster.h. So every place where he wants that class declaration included, he includes roster.h. And you'll notice he's using quotes rather than, rather than those inequality operators. And the reason is that the quotes say that it is user-defined or programmer-defined. So the quotes say it's programmer-defined. I have to abbreviate. If you use the arrows, it means it's system-defined, meaning it comes from something that C++ defines. Okay? So everywhere you want a class declaration, you are going to include that .h file. And effectively what happens is C++ copies the whole contents of the .h file into here using a preprocessor. So the preprocessor takes whatever the contents of the .h file is, it replaces this include statement with the contents of the .h file. Okay? So, next time, which I admit I will not be here next time, but on Tuesday, that lecture starts up with how we now do what is called multiple file compilation, where we're going to use multiple files in order to compile our program. So that is where the video lecture starts on Tuesday, and that is where we end here today. Remember, no class on Tuesday or Thursday of next week, but you are responsible for the video lectures.